If you had any doubt about high energy at Griffith Observatory, you shouldn't.
Hello, I'm Mark Pine, and you're at the Griffith Observatory. Let's go inside for a tour.
Hello everyone, I'm Dr. Ed Krupp, Director of Griffith Observatory, and Griffith Observatory is in fact the most visited public observatory on the planet. It is owned and operated by the City of Los Angeles Department of Recreation and Parks. Now, if you travel around the world to various museums, you'll find that other places have a Foucault pendulum to do the same thing that it does here at Griffith Observatory. But there is no Foucault pendulum on Earth like this Foucault pendulum, and it all has to do with the rest of the place. You have to look at where this pendulum is, and you start on the ceiling. If you look overhead, we have these wonderful murals on the ceiling that are astronomical allegories. They're all about the mythology of the sky. You can see Atlas holding up the heavens, and the various figures of the zodiac, Orion, the Pleiades, the planets, all are up there. But then as you make your way down that wire of the pendulum, that axis of the room, you come to the murals on the walls. And they're not mythology, they're the sciences. Astronomy and aeronautics and navigation and time and engineering. And as you keep coming down the axis, you wind up at the pendulum itself, which is, of course, an astronomical instrument telling us what the world is doing. The pendulum is showing in real time that the Earth is turning. Now, most of us know that the Earth is turning, but we don't feel it at all. This pendulum actually shows that. It shows it because it's swinging back and forth, and Newton's laws tell you that it can't change its direction unless something pushes on it. Well, nothing is pushing on it here. But as you watch the pendulum over a period of time, you will notice that the angle at which it's swinging compared to the floor is shifting. In fact, we have some pegs down on the floor that are set up to be knocked down every few minutes or so as the pendulum comes along and swings into them and sets it over. So the pendulum at Griffith Observatory is a primary instrument. Again, an instrument that shows how the universe is working, at least as far as the Earth is concerned, and that turns everybody into an observer. There's always high energy at Griffith Observatory, but especially here at the Tesla coil.
Hi, I'm Katie, your museum guide here at Griffith Observatory. We're going to talk about one of my favorite attractions, our Tesla coil, and you can see it over here. We're going to zap it for you and I'll tell you a little about it. Pretty cool, right? This is Nikola Tesla's creation, ladies and gentlemen, and this instrument distributes very high voltage currents of electricity, up to 500,000 volts or more in each current, compared to a flashlight which only uses 1.5 volts of electricity. And this instrument creates a wireless electric field. There's actually a wireless electric field inside this room, you guys. Don't worry though, we have this copper cage lining the room here protecting us. When I turn it on, you'll see this fluorescent, colorful sign light up inside the room. No outlets or wires over there, just the electricity inside this room making it happen. And Tesla was really interested in wireless electricity. It really never came to fruition, but we have this great attraction here at Griffith Observatory. It's one of my favorite exhibits, donated to the city back in 1937. This instrument is over 80 years old, you guys, and we're hoping to keep it going for another 80.
We're here in the Wilder Hall of the Eye at Griffith Observatory, and in this room we deal with everything the eye can do with the sky. And of course, people first started watching the sky with only their eyes, but eventually the telescope was invented and first used for observing the heavens. The person who gets the credit for that is Galileo. And Galileo, actually in 1609, was probably the very first person to make serious observations with a telescope. A perfect replica of his telescope is in the case right here. Now, the real telescope is in Florence, Italy, but Griffith Observatory was privileged to examine it in detail, and our instrument makers fabricated an exact replica. This telescope, of course, is nothing like the telescopes of today, or even just a few hundred years ago, as it was the very first time anybody really tried to look at the moon or planets like Jupiter and Saturn through a telescope. But the telescope that is behind it, also not a huge modern telescope, is extremely important for Griffith Observatory in Los Angeles. This telescope is the first telescope, the first scientific telescope to come into Los Angeles. And of course, it's here on display at Griffith Observatory. But of course, the telescope that most people want to see at Griffith Observatory isn't in this room, it's up on the roof. It is daytime right now, of course, and that means the telescope isn't really working. This telescope operates, obviously, at nighttime to see the moon, the stars, the planets. But at nighttime, when the observatory is open, this telescope then starts getting a line ready for the place to open at 7 p.m. That's the telescope that becomes open for the nighttime viewing. Observatories, of course, are supposed to have telescopes, and this is Griffith Observatory's famous Zeiss refractor. This telescope, of course, isn't Griffith Observatory's only telescope, but in fact, it is the observatory's first telescope. This was in place when Griffith Observatory first opened in 1935. And like the rest of Griffith Observatory, it is open to the public for free. That's what Colonel Griffith had in mind when he left the money to build Griffith Observatory in his will. Now, there are telescopes that are much bigger than this refracting telescope at the observatory. There are telescopes that are much more powerful. But in a way, this might be one of the world's most important telescopes because more people have looked through this telescope than any telescope on Earth. Now, this telescope doesn't just point itself. Griffith Observatory has telescope demonstrators that are working here each night in order to operate the telescope for the public. And you have to move the telescope to the right direction in the sky in order to get the object you want to see, whether it's the moon, a planet, or some star cluster. We know where those objects are in the sky by mapping their positions. And this telescope is designed to allow you to point to positions. There are two big circles, one right here and another here. And those, in fact, are used to align the telescope. You turn it around one way and you turn it up and down the other way in order to get the telescope exactly where it should be. This is, of course, just rough pointing, but then there are paddle wheels up here. There are hand controls that you use for the fine tuning.
So guys, check this out. Super cool. We're rotating our Zeiss dome. It rotates 360 degrees. We can point it to any direction we want in the night sky and look at any object anywhere that's visible up there.
We are in the Gunther depths of space here in the lower part of Griffith Observatory, and this is the gallery where we talk about the modern universe, the universe that was created with large telescopes and spacecraft that went into space. And one of the fun facts of this gallery is the planet models you see behind me. They're all accurately sized to each other. So you see the size of the Earth, and then you see how much bigger Jupiter really is in comparison to the Earth. And the even more amazing thing about the models is that they're all scaled accurately to the size of the theater, which is the diameter of the Sun. So you get an immediate sense that as big as Jupiter and Saturn are, the Sun is massive. One of people's favorite things to do here in the depths of space is to weigh themselves on each one of the planets. Each planet has its own scale, and the scale measures the force of gravity on that particular planet, and they aren't all the same. I'm going to step on Jupiter now. I normally weigh 170 pounds. It's not going to be quite like that on Jupiter. I think I may have had too much for lunch. Another thing not to miss when you're at Jupiter is this. We call it the turbulent orb, but what it really does is it shows how clouds on Jupiter move at very different rates depending where they are on the planet. All you do is spin it like this, and you see that the clouds here near the pole orbit very slowly, the ones near the equator very quickly. And that's actually the way that the clouds on Jupiter actually move. So the fun fact about our turbulent orb is that to make this wonderful complex effect, what's inside is water and soap. The kind of soap that sort of shimmers when you're washing with it. And it makes this wonderful effect where it looks like clouds. It was made by the Exploratorium in San Francisco. We bought this from the Exploratorium in San Francisco in 2006. Here at Pluto, and Pluto is part of our exhibit because it's an interesting part of our solar system. It's not a planet, it's a dwarf planet, but it is still a really interesting place, and it illustrates a very interesting fact. If you go to Pluto and you could stand on the surface, you would weigh a lot less than here on Earth. Pluto has so much less gravity than the Earth that here on Pluto, I only weigh 20 pounds. So I can have more lunch. So a fun fact about what I'm doing right now, which seems very odd, and even more odd is who's sitting next to me, the most famous scientist of the 20th century, Albert Einstein, is that there is actually a purpose to this strange behavior. And that is, if you went out tonight and you held your finger 1 foot from your eye against the night sky, in Los Angeles you probably wouldn't see anything. But if you went out in the desert, it would cover a couple stars maybe, but what it really represents is what's on the big picture. All the galaxies, all the stars, every finger of sky is the big picture. Everywhere you look, space is filled with objects. So the remarkable thing about the big picture is that it shows what the universe is really like. And what the universe is really like at its core is that it's composed of galaxies. Everywhere you look, in every direction, it's filled with these giant collections of stars. Hundreds of billions of them make up a galaxy, just like our own Milky Way galaxy. So this is a galaxy, and this is a galaxy, and this is a galaxy. And the reason they're different sizes is that some of them are farther away from us, and so they look smaller. They're roughly similar in size for the most part to each other, but the difference here is because they're farther away. Even this little blob right there is actually a galaxy. It might be hundreds of millions or maybe even over 1 billion light years away, which means that the light that it's emitting, that's captured here on the big picture, left there 1 billion years ago. The amazing thing about the big picture is that it is not a painting. It is not starry wallpaper. It's real data that was collected by a real telescope, the Samuel Oschin telescope at Palomar Mountain. And it was real data, 6 weeks worth of observations that were processed by the Caltech supercomputer, and all of the data was collected by a team at Caltech that we could then put onto the wall to have this incredibly large image of the way the universe actually looks. This is what you would see if your eyes were telescopes that were 36 inches wide. We're here at the Griffith Observatory exhibit dedicated to our moon, which is the closest satellite of the Earth. It is the closest celestial body to the Earth, and it is the only place that humans have gone in space where they actually could step down on the surface that wasn't the Earth. And this rock right here is a piece of the surface of the moon. It was brought back by the Apollo astronauts on the Apollo 14 mission. They picked it up off the ground. It's actually shown in this picture here. You can see this big rock right there. That's called Big Bertha. And this is a chip off of that rock that was loaned to the observatory by NASA so that people could see a piece of the moon. So a fun fact about our Apollo moon rock is that it was loaned to us by NASA. And when you get a loaned rock from NASA, they're very, very interested in security and safety of the rock. And so they won't ship it to you. You have to go physically pick it up in Houston at the Space Center. And so we sent someone who worked for Friends of the Observatory to Houston, and she picked the rock up and she took it to the airport and she put it on the TSA scanner, and everything shut down because all the TSA agents came over to see this moon rock. They'd never seen one. And she carried that onto the plane, brought it directly to the observatory when she landed, and we put it in our safe, and then when we were ready, we put it on display here so that you could see it.
If you visit Griffith Observatory, you can't mistake the building. It's got those 3 distinctive domes. There's one on either side. Each of those, in fact, houses a telescope. But the big dome in the center is, in fact, the dome over the Samuel Oschin Planetarium. That's where we are right now. The Samuel Oschin Planetarium is a theater for audiences to get a chance to see any aspect of the universe that we're presenting with the Zeiss Universarium Mark 9 projector that's over my head right now, and all of the other technological wonders that make this theater operate. All dome digital animation, musical soundtrack, and a live person to deliver the show. These programs, in fact, may transport you perhaps to Stonehenge or ancient Egypt, to the far corners of the universe, the Orion Nebula, and always will bring you back safely here to Earth. All of the chemical elements are part of Griffith Observatory's collection of the elements in this cabinet, except of course for those radioactive ones that just disappear in less than a split second. But this exhibit at Griffith Observatory also tells us where these atoms originated. For example, these are the elements that originated in the Big Bang, the origin of the cosmos, 13.8 billion years ago. Then there was just hydrogen and helium and a little bit of lithium. There are a lot more elements than those, however, and many of those are produced by the stars in thermonuclear fusion. Those stars have made the other elements over time. In addition to that, certain kinds of stars that explode catastrophically, the supernovae, produce even heavier elements. And so all of the elements that we know in the universe come from the beginning, the Big Bang, from stars, and from supernovae. And these are the elements in us. All of the elements of us, in fact, began in the stars. On a visit to Griffith Observatory, if you descend gravity's stairway from the historic level where the Foucault Pendulum and many of the other exhibits are located, you'll come to the center of gravity, and here at the center of gravity is the start of the cosmic connection. The cosmic connection is a timeline of the universe that extends all the way down this corridor. It begins right here with the Big Bang 13.8 billion years ago. But our ribbon of time through all of those billions of years up to the present is measured with a ribbon of jewelry, a ribbon of celestial jewelry, suns, moons, and stars, comets, everything. All of this jewelry that carries us through the history of the universe is really the collection of one woman. She never wore it all at the same time, but she gave it to Griffith Observatory for this purpose. So we started the Big Bang 13.8 billion years ago, and if I just walk this far, I have walked 1 billion years of cosmic history. And the panels up above tell you what's going on at that time, from the Big Bang to the formation of the very first galaxies, and ultimately the present way down at the end. walk down the cosmic connection, 13.8 billion years of accessorized time with that ribbon of jewelry to wind up at the present. And we look back just a short ways to about 3.6 million years ago, where the panel tells us that our cousins left this footprint in the volcanic ash at Lake Tole in Tanzania and Africa. And practically yesterday, we left a footprint on the moon.
We're really glad you could join us here at Griffith Observatory today, and we look forward to when you can come and visit in person. You can see the exhibit galleries, you can look through a telescope, you can enjoy the wonders of the Samuel Oschin Planetarium. You can make a connection with the cosmos. Griffith Observatory is your observatory. It's where the stars are the stars. And until then, on behalf of everyone here, I really want to thank you for visiting.